continue on indefinite integration. In the previous lecture, what we have done is talk about substitution method a lot. Today also we are going to continue on substitution method, but along with that we are going to talk about by parts technique also, and some different formulas, some special integration also. Okay, so make sure that you stay tuned till the very end, because indefinite integration is somewhat a little bit heavy chapter. So you have to have some patience, you have to do hard work in this chapter. So make sure that you are doing that. And just in case you're new to the channel, this is my brief introduction. My name is Namrata and I have over a decade of teaching experience in both online and offline. These are my credentials, as you can see. And without wasting any time, let us quickly start with the session. In the last class, we have seen substitution. Now we are going to start with trigonometric substitution. So it all depends upon what kind of expression do you see, and based on that you are going to put that trigonometric ratio. This we have also seen in ITF, inverse trigonometric functions. Whenever you see a square plus x square, what do? You put a tan theta or a cot theta. Whenever you see a square minus x square, what do? You put a sin theta or a cos theta. Whenever you see x square, see, understand, over here, if you're going to put sin theta, it will not work. Why? Because it will then become 1 plus sin square theta, which is not making any sense. But 1 plus tan square theta is a formula, is an identity, which is sec square theta. That's why. You don't have to remember it. You just have to understand it. Okay? X square minus a square. So if you put sec square, a square will be common. Sec square minus 1 is tan square. So a sec square and cosec only will work in this. Now if you see both together, a minus x and a plus x together, if you see it, then you put a cos 2 theta, because we have two gold formulas. So if you put a cos theta, a will be gone. 1 plus cos 2 theta will get created, which also have a formula. 1 plus sin theta also have a formula. Okay, so that's how it is. But yes, let's solve a couple of questions so that you absorb it a little better. Okay, you will be able to understand. For example, integration of this. Now I don't know how many of you know, but what is the derivative of sin inverse x? In differentiation chapter we have studied this. It is 1 upon square root 1 minus x square. Same over here. Can you see? Now integration, let's generalize this. So integration of this will be sin inverse. Okay. So dx upon square root a square minus x square is sin inverse x by a. Let's prove it. Okay. So whenever I told you now, this expression a square minus x square tells me that put x is equals to a sin theta. Now differentiate. Dx is equals to a cos theta d theta. Okay, so now integrate from here. Integration, dx will be replaced by what? A cos theta d theta upon square root of a square minus x square. Okay, a square minus x square. X square is a square sin square theta. A square, if you take common, you will realize that a square will become a and it will become a cancel out. So 1 minus sin square theta is what? Square root of cos square theta, which is square root of cos square theta is cos theta. Cos theta cancel. So just d theta. So integration will be theta plus c. What is theta now? So ma'am, theta is x upon a and then sin inverse. So sin inverse x by a plus c. Let me know. Let me know. Is this clear? Give me a big thumbs up if this is clear. Okay? Easy, not very difficult. Now I will give you 3 important formulas based on this. First, you know, square root of a square. See, understand. Here there is no 1 by a over here. Some students get confused, and you know what? NTA plays on exactly that. they will give you an integration and they will write the answer also, and they will write that 1 by a sin inverse x by 3. Now what is the value of a? In sin inverse formula, there is no multiplication in the beginning, right? So make sure that you do not get confused. But you know what? In tan inverse formula, there is 1 by a tan inverse x by a. So this is your homework. Just prove it. Okay, put x is equals to a tan theta, then take common. What will happen? A square, it will come out. 1 by a square, it will come out, and it will be what? 1 upon 1 plus tan square is sec square. So integration of cos square theta. Like that it will go. Okay. And dx upon mod x square root x square minus a square is 1 by a sec inverse x by. Can you see? In fact, this formula also having 1 by a, this also 1 by a, but this is not having 1 by a. Okay, right? So this is how substitution works. Alrighty everybody, yes. Now just quickly solve a problem so that I can understand whether you have got the gist of these problems or not. Solve it quickly. Elementary problem, huh? Let me adjust my hairstyle a bit. Perfect. You guys must be having, especially girls. You girls might be having that hairstyle, na? That one hairstyle which you make while you study, so that your hair doesn't irritate you. I also have a hairstyle. While teaching, I don't want anybody to irritate me. Okay. So integration of 1 upon x square plus root 5 whole square dx. Okay. So now you know the formula, 1 by root 5 tan inverse x by root 5 plus c. Easy? Yes. Now solve this. Okay. How will you solve it? See, 2 plus 5x square. Can I write it as 2 plus 2x square plus 3x square? See, you have to hit and trial. Now just divide it by x square 1 plus x square and x square 1 plus x square. Integration, integration. Okay, clearly 1 plus x square and 1 plus x square will be gone. This will be 2. So this is integration of 2x power minus 2 dx plus x square cancels, so 3 1 upon 1 plus x square dx. Okay. Now x power minus 2 plus 1. So this is 2 minus 2 by x plus 3 tan inverse x plus c. Easy. Only if you can like separate it out. This step is important. Then only you will be able to do it. Right or wrong? Yes? Next. Now see. Dx upon square root of a square plus x square. Another formula on your screen, okay? I know now today's session is going to be a lot of formulas, but you know what? I'll make sure that you remember it also. See, 1 upon x square plus x square, so you know now. You know that 1 upon x square plus a square is what? 1 by a tan inverse x by a. Now there is a square root over here. So the moment square root arrives, it will become log. Okay, so the answer is log of mod of x plus copy paste. Okay, do you want me to solve it? I can solve it also. Put x is equals to a tan theta. So dx will be what? A derivative of this is sec square theta d theta. So integration of a sec square theta d theta upon square root a square plus x square. So a square will come out, it will become a. 1 plus tan square theta is sec square theta. So sec square theta, so it will be what? A cancel, integration of it is going to be just sec theta. Now integration of sec theta, you know, log of mod of tan theta plus sec theta plus c. So log of mod of. Now understand, tan theta. Tan theta is what? Tan theta is what? X by a. X by a plus sec theta. So ma'am, sec theta will be what? Square root of 1 plus tan square theta. So 1 plus x square by a square plus c. If you solve it, it will go here, and you know what? Log a will be adjusted in constant. So log of x plus mod square root a square plus x square will be there. Here a will what happen? See, this is upon a. So log of something, log of, basically this is coming out as log of this upon a, right or wrong? Now we know the formula, right? Log a by b is log a minus log b. So this is minus log a. If you remove it, it will become minus log a, which is a constant again. So this is the answer. Yes? Okay. So it is not very difficult also if you forget the formula sometimes. I mean, don't completely forget it, but yes, if you are forgetting it sometimes, so you can actually think about it, how to do it. Substitution. See, here what you need to put, see, this is the formula. Now I think this is not going to be very difficult for you, because you know what? See, x square plus a square, this is x square minus a square. Same thing, log of mod of x plus copy paste. These two formulas are same only. You just have to remember the format. Log of mod of x plus copy paste. Okay. Now what about this? Dx upon a square minus x square. So the formula will be 1 upon 2a ln mod. Now see, understand. If you split this, what will happen? Ma'am, a plus x and a minus x. So a plus x upon a minus x mod close plus c. So that's how it is done. Okay. So remember these three formulas, because yes, we are going to apply these formulas. Okay. Now this. Find this. So very easy, ma'am. Log of mod of x plus square root x square plus 4 plus c. Done, done, done. Not a very difficult thing, right? Okay. All right. What about this now? Okay. E power x minus 1. Think about it. Think about it. How will you solve it? Just tell me what will be your first step. e power x upon square root of e power 2x minus 1 integral minus integral of 1 upon square root e power 2x minus 1. Okay. So e power, this is e power x square. So I am putting e power x is equals to t for this one. So e power x dx will become dt. So this is dt upon square root of t square minus 1. I think this we can do it, right? This is log of mod of t plus copy paste. Plus, what about this? Not plus. What about this now? Okay. So what if I multiply e power x and put e power x is equals to t? So e power x dx again will become what? Dt, and this is upon t square root t square minus 1. Oops. Can you see? Can you see? What is this? Huh? This is sec inverse t. Sec inverse t plus c. Now just put the value of t, which is e power x, and write your answer. So log of mod of e power x plus square root of e power 2x minus 1, okay, minus sec inverse e power x plus c. This is your answer. Okay. All right. Yes? Clear? Chalo. Next question, let's say. Let's see next question. Now what will you put t? Quickly. Now it should strike quickly in your brain. Yes, Gokul. Put x square is equals to t, because then 2x dx will become what? Dt. So over here, x dx will be dt upon 2. And this is what? Now x square is c to t square minus 1. Okay, so 1 by 2. Okay. Now let me tell you, we remember this formula, 1 upon a square minus x square integration is what? Log of mod of a plus x upon a minus x. But you know what? Here things are slightly different. You need to take minus sign common, so that you get 1 square minus t square. And now you can integrate. So this is minus 1 by 2. Multiply, don't forget 1 by 2a. Multiply 1 by 2a. Okay. Now log of 1 plus t upon 1 minus t plus c. So this is going to be 1 by 4. But you know what? This minus sign. So this minus sign, I will remove it from here, apply it here. So it will be minus 1, reciprocal of it. So 1 minus t will come over here, log. Log of 1 minus t upon 1 plus t plus c. So this is 1 by 4 log of mod of 1 minus x square whole upon 1 plus x square plus c. Okay. Yes. Yes, actually you can, So this is the answer, right? Okay. Now, see, remember that chart we have seen in the last class where we saw that techniques of integration. Number 1 was substitution. Then the second one was by parts. The third one was partial fraction, and the fourth one was miscellaneous and putur. So now we are going to focus on by parts today. Okay. So by parts, majorly we are going to go about by parts, and let's see if we can do partial fraction today or not. Let's see that. Okay. Yes. So now u and v are two functions of x. Integration of u and v. So when there are two functions, you know how to differentiate that. Now you have two functions, you should know how to integrate that. So what will you do? First of all, you will decide which one is going to be the first function, which one is going to be the second function. Okay? Like differentiation it doesn't matter. First or second doesn't matter because it's symmetric. But in here, deciding on first and second is different. Okay, the answer will be completely different if you decide that this is my first function, and answer will be completely different if you decide my second function is this. Okay. Now, how to decide that we will see, but right now let's see the formula. Integration of first and second is equals to first function constant integration of second. First function constant integration of second minus integration of derivative of first. See, whatever you have written constant over here, now you have to differentiate that and then multiply, you have to integrate the second function. And overall the combination eventually you have to integrate. Okay, we'll do it, we'll understand it, then only you'll be able to learn this. But ma'am, how to decide? How to decide on first and second function? For that we have Eilert rule. Okay, Eilert rule says that the preference will be given in this order. The first priority will be ITF. So whenever you see two functions and you see sine inverse x or cos inverse x or tan inverse x, mark this as first function. Then logarithmic, if you see, okay, so logarithmic and algebra. Logarithmic will be first and algebra will be second. Okay, so in this exponential will be the last, Eilert. Okay, so inverse, ITF, logarithm, algebra, trigonometry, exponential. Okay, function which comes later is taken as integrable. Now why it is happening? Because see, inverse trigonometric function, we do not know the integration of sine inverse x. Do we know? No. Have we seen any formula? No. We have no formula for integration of ITF. We have no formula of integration of log x also. But we do have formula for e power x. We do have formula for normal trigonometric function like sin x, cos x. So if you see, the second function is actually, we need to integrate the second function in this formula. So basically think about this, think about this way also, that the second function should be integrable and first function is something which we find difficulty in integrating. Okay, all right, so let's do one question. Chalo, let's do this. X tan inverse x. Obviously the first function will be inverse and the second will be this. Now what is the formula, ma'am? The formula will be first function constant integration of second minus first function constant integration of second minus integral of derivative of first function. That means differentiation of whatever you have kept constant and integration of second. And overall you have to finally integrate also. So this is tan inverse x, x square by 2 minus 1 by 2 if I keep common. So what will happen? This is x square upon x square plus 1. So what I'm going to do is I'm going to add 1 and subtract 1. And you know what? You have to integrate this. Adding 1 and subtracting 1. So this is x square by 2 tan inverse x. Slightly lengthy process, but x square plus 1 cancel. So it will be 1. Minus half is already there. So minus half integration is x by 2 minus minus plus. See, understand, minus minus plus 1 upon x square plus 1 integration is tan inverse x plus c. So now this is your answer, match it. X square by 2. So ma'am, B and D is wrong, there is no x square by 2. B and D is wrong. So x square by 2 tan inverse x minus x by 2. Acha, let's not forget half is also there, no? This half will get multiplied. So half is there. Option A looks correct. Have a look, let me know. See, I'll write the formula first function constant integration of second minus integration of derivative of first and integration of second and the whole integration. Clear? Yes? By parts? Not very difficult, right? Chalo. Ninja technique coming on your way, by the way. X square sin x dx. Do we have, let's do this first. Integration of log x. Now ma'am, we don't know this formula, integration of log x, and there is only one function. So by parts is also not applicable. Islet mein L logarithm is coming on the second number. Okay, so what we are going to do is, we don't know the formula, so we will just multiply it with 1 so that this becomes first function and this becomes second function, and now apply the formula. What is the formula, ma'am? First function constant. Okay. Integration of second function. Okay. Integration of 1 is x minus integral of derivative of first function. Okay. Integration of second. Okay. So this is x cancel, this is 1 only. Right or wrong? See. X cancel. So this is going to be x ln x minus, now integration of 1 is x plus c. And I have to remember it, x log x minus x. X log x minus x. So integration of log x, remember it. X log x minus x. Log x is such a important function. You should remember, even if this is not a formula, but you should remember it. X log x minus x is the integration of log x. Okay? Alright? Yes? Now, one question I will give you, and this was asked in JEE in January 2019. Slightly tricky, but not that tricky. Okay? First of all, the moment you see this question, what strikes in your brain? Tell me. See, the very first preference of every JEE aspirant and every maths teacher is also that I don't want to use by parts. If at all I can use substitution, then I will go. That is my first preference. Yes or no? Substitution was much easier. I mean, by parts is also not very difficult, but still substitution is something which comes with very ease. Automatically things fall in place. So right now, can I do it with substitution? Let's see. So if I put minus 4x cube is equals to t, what will happen? So ma'am, it will be minus 12x square dx will become dt. Okay. So x square dx. Now understand, I am going to write x power 5. X power 5 will be what? X cube, x square and e power minus 4x cube dx. Okay. So here x cube will be what? Minus t by 4. Minus t upon 4. Okay. X square. What is x square? In fact, x square and dx together will become dt minus dt upon 12. Okay. And. One more thing. We have, can you see this e power t? e power t is also there. So finally, what do we have? 1 upon 48 integration of minus minus plus t e power t dt. Now this is much easier. This looks much easier, right or wrong? T e power t. So Eilert rule, exponential will become last. So this is my second function, this is my first function. Now 1 by 48 is there, it is there already in the function also. Start integrating. 1 by 48 I will keep outside. First function constant, integration of second function minus integral of derivative of first. So derivative of t is 1 and integration of second e power t dt. So 1 upon 48. Now start putting the value also t. What is t? T is ma'am minus 4x cube e power minus 4x cube minus integration of e power t is e power t only minus 4x cube plus c. So now if you can take common also, e power 4x, if you can take common this and this, so it is going to give you what? 1 by 48 e power minus 4x cube, inside the bracket we have minus 4x cube minus 1. Okay, so this, if you compare, fx is actually matching with this or not? So B option is absolutely correct. Not a very difficult question, is it? Is it difficult? Okay. Now this question. Sometimes what happens if you apply by parts? What will happen? You are going to stuck in the same loop. See, this is out of integration also. How many of you feel that it happened with me, that we start a question and then eventually I made a shorts also out of that, 16 minus 9, 4 square minus 3 square, 4 plus 3, 4 minus 3, then multiply, then cancel, again 16 minus 9. Oops. Basically, we completely solve it and we get the same thing or sometimes similar thing also. So if we feel that all of that which we have solved, we are stuck in the same loop. Okay, but not exactly same. This is not exactly same, but you know what? You start solving it, you will realize that okay, it is happening. Let's see, solve it. X square sin x. Now I late. So I think first function is algebraic and second is sin x. Now apply the formula, ma'am. First function constant, integration of sin x is what? Minus cos x minus integration of derivative of first function and integration of second will be what? How many of you actually are getting this? Is it difficult or am I applying too fast? Am I applying the formula too fast? That also tell me. Are you able to do that with me? Okay, so now again, can you see you are stuck in that same by parts thing? Algebra and trigonometry together, by parts is the thing. So now again, this is your first, this is your second. So it is going to be x square plus. Now first function 2 is already there. First function constant, integration of cos x is sin x. First function as it is, integration of second minus integration of derivative of first and integration of second. That's it. So finally what will you get? Not here. Minus x square cos x plus 2 x sin x minus, now sin x integration is plus cos x. plus c. This is your answer. So minus x square cos x. So I think this and this. B option is wrong. Plus 2x sin x. So I think B and C both are wrong. Plus 2x and plus cos x. Option A is absolutely right. Yes, this is a normal method, but are you interested in ninja technique? Okay. In that case, what you have to do is ninja technique. It is applicable. See, it is applicable when you have actually, when the recurring biparts is there. This is of the type recurring biparts, multiple. Now imagine this is the x square. So you were stuck in only one loop. But suppose it is x cube, then what will happen? So ma'am, if at all it is x cube, then the answer would be here it will be 3x square. So x square cos x. One more step it will take, here it will be x sin x, one more step. And imagine if it is x power 4, 3 loop, x power 8, multiple loops. Oh my god. Then the x power 8, so you won't be able to solve it. You will take 15-20 minutes. More than that, you will be exhausted. Okay. So in that case, what you need to do is, you need to use DI method. What is DI method? DI method mein, you have to keep that x square as it is. And you need to integrate sin x. Okay, ma'am. Integrate sin x, ma'am. Integrate sin x is minus cos x. Okay, the first is plus sign. Now apply the negative sign over here, and now you just differentiate x square, which is 2x. Okay, so d. And integrate minus cos x. If you integrate minus cos x, tell me, this is I. Integration of minus cos x will be what? So ma'am, integration of minus cos x will be minus sin x. Again di. 2x है ना, तो अभी देख see plus then minus. This sign will be plus now. Then again d. So derivative of 2x is 2, and integration of minus sin x is minus cos x, so it will be plus cos x. Okay, and after that what will happen? You have to differentiate 2, which is going to be 0. So that's it. We are going to stop it over here. So answer will be what? X square minus x square cos x plus 2x sin x plus 2 cos x. Can you see? DI method. X square kept as it is, sin x got integrated. Now what will happen? X square will be differentiated 2x will be differentiated 2. Minus cos x continuation integration. Minus cos x integration is minus sin x integration is cos x. Getting it? Getting this ninja technique? Don't worry, because we have more questions. We'll be doing more questions on ninja technique also. Okay? But for now, let's do this question. JEE Main September 2020. Integration of sine inverse square root x upon 1 plus x. Okay. Try. Okay. So now, see, for sure there is going to be a trigonometric substitution in it. How many of you understand it? For sure. Right now you cannot even integrate. In fact, sine inverse integration, so you don't know. You have to substitute something which is trigonometry over here. Now 1 plus x. You have to substitute such value or such trigonometry thing so that both x and 1 plus x will get free from root. 1 plus x. So suppose you put x is equals to tan square theta. Then what will happen? So ma'am, dx will become what? 2 tan theta sec square theta d theta. Integration of sine inverse square root x is what? Tan square theta. So square root of tan square theta will get free. 1 plus tan square theta. Okay, dx will be what? 2 tan theta sec square theta d theta. Completely in terms of theta now. Okay, so what is this? Integration of sine inverse. Now this is tan theta upon sec theta. Tan theta upon sec theta is what? Tan upon sec is tan into sec. Sorry, tan into cos. This is sine theta. So sine inverse sine theta. Okay. Then we have 2 tan theta. So this is 2 sine theta. Sorry, this is going to be, understand. Tan is what? Sine by cos. Okay, and this is, oops. So this is going to be 2 tan theta. Okay. Let it remain as it is. 2 tan theta sec square theta d theta. Okay. So this is going to be what? Integration of theta. 2 is outside. Then we have theta is there. Okay. Then we have tan theta, or we can write sec theta. Sec theta, then we have sec theta, tan theta. Okay. D theta. Okay, now things are little complicated over here. Not that complicated actually, not complicated, it's tricky. Now obviously biparts will be there because see, theta is an algebraic function. X sin x. X is algebra, sin x is trigonometry. Theta sec theta. So theta is algebra. Okay, isolate. So this is going to be your first function. But who is going to be the second function? And you know what? Second function integration you should know. So that means, ma'am, do we know the integration of this second? If I assume that this whole thing is second, do I know the integration of this? Sec theta, tan theta. Let's see. So we need to find the integration of sec theta, tan theta, d theta. Let's see. Do we know if this is my second function? Then there is a multiple usage. Okay. So if I put sec theta as t and sec theta d theta will become dt. So yes, now we can integrate it, t square by t. So sec square theta by 2 is the integration. How many of you are getting it? Very interesting. So whenever this is the second function and whenever we need to write the integration of second, what are we going to write? Sec square theta by 2. Okay, so in that case, 2 is already outside. First function constant. Integration of second function. Ma'am, sec square theta by 2. Okay, minus integration of derivative of first. Derivative of theta is 1 and integration of second, sec square theta by 2 plus c. Yes or no? Am I doing anything wrong? Okay, this is correct. Sec square theta is there, na? So, if I put sec theta, what is derivative of sec theta? Sec x derivative is sec x tan x. So this is t sec square. Okay. So now 2 is getting cancelled out. So now the answer is theta sec square theta minus, what is this? Integration of sec square theta. Integration of sec square theta. Do we have any formula for this? No. Integration of sec square theta minus integration of sec square theta. How to integrate this now? I think will be done once we are able to do that. Sec square theta is 1, this is 1 plus tan square theta. So integration of tan square theta. Yes, integration of sec square theta is what? Tan theta, no? So theta sec square theta minus tan theta. Absolutely. That's it. Done, done, done. Okay. So now this is your answer. Theta. Let's change it now. What is theta? Theta is root x. See, from here I can write tan theta is equals to what? Root x. Okay. So theta is tan inverse root x. Theta is tan inverse root x. So here I am going to write tan inverse root x. Tan inverse root x. Okay. What is this sec square theta? See, sec square theta is nothing but 1 plus tan square theta. So 1 plus tan square theta is, so this is 1 plus x. Yes? Okay. So theta is tan inverse x, tan inverse root x. Sec square theta is 1 plus tan square theta. 1 plus tan square theta means 1 plus exactly x. Okay. Now, minus tan theta. So minus, what is tan theta? Root x. Plus c. This is your answer. Now compare. See, this and this are exactly same. So your A is nothing but 1 plus x. What about B? B is minus root x. So 1 plus x and minus root x, option B is absolutely correct. Yes? Okie dokie? Clear? Good question, right? Now, how to integrate sec cube x? And this is a recurring model. That means what you have to do is, sometimes, again I told you now, you start with something and you get the same thing. Okay. So let's start at sec cube x. So what I'm going to do is, sec cube x can be written down as sec square x sec x dx. Okay. Sec square x. What is sec square x, ma'am? 1 plus tan square. So 1 plus tan square x and sec x dx. Yes? Actually not like that, sorry. Yes, here only we should think about putting first and second function. Now understand, we just did, by the way, the integration of sec square x is tan x. So we know the integration of this, so it will be second, and we don't know the integration of sec x. I mean, we know, but sec square integration is much more easier to us. So that's how it is. Now apply by parts. So I is equals to, let's assume that this is your I integration. I is equals to first function constant. Second ka integration is what? Tan x. First function constant, integration of second function minus integration of derivative of first function. What is derivative of sec x? Derivative of sec x is sec x tan x. Okay? And integration of second will be just tan x dx. Okay? Alright. Now this is what? Tan square x. Can we do something about it? So this is sec x tan x minus this is sec x and tan square x. What is tan square x? Sec square x minus 1. Okay, now if you solve it, do you even realize that what is going to happen? Sec cube x. So minus sec cube x, which is the original question. So can I write minus I minus plus integration of sec x dx? Yes? So I plus I. Now what will happen? 2i. So whenever, see, exactly same, you started solving it and eventually you realize, oops, to solve this I need to have I only. Okay, see, this is I only. You require integration of sec cube x to find integration of sec cube x. Funny, isn't it? But there is a technique. You write I and it will going to be 2i. This is sec x tan x minus integration of sec x. So we know log of mod of sec x plus tan x. Yes. So this is what we call as recurring model. Recurring model means that you start something and in between you get the same integration. That's a good news. That's not a bad news. You write it I and you get it. So that's why in the beginning only I assumed it as I. So please do not forget the last step because 1/2 should be there. Okay. So this is how it is. See, this is the answer. Clear? Sec cube x. So sec square was the second, sec x and sec square x dx. First, second. First function constant, integration of second minus integration of derivative, so same thing. And then eventually I took it it is u here, so it is going to be like that. Okay. Do you want to try a question? Let's see, a JEE main PYQ based on recurring model. Based on recurring model. I want all of you to try it. Now obviously 1 and dot. Okay, so this is first, oops, this is first and this is second. I is equals to first function constant, integration of second, minus integration of derivative of first function, derivative of cos. Derivative of cos is minus sine, so therefore sign will change, sine of ln x. Derivative of cos of ln x, right? So derivative of cos is minus sine, ln x is kept constant. Chain rule, log x derivative again because of chain rule, so log x will be differentiated 1 by x. Okay. Now integration of second, that means x dx. X constant. So I is equals to what? X cos of log x plus, can you see again similar, integration of 1 dot sine log x. That's how we are going to integrate. We are going to again apply by parts over here. Now in here this is second and this is first. I is equals to x cos log x plus ma'am trigonometric function cos of log x. This is what? Trigonometry completely. And I have told you also that, think about it, the second function should be that function whose integration should be known to you. The second function should be that function whose integration should be known to you. Do you know the integration of cos of log x? And this is a combined function. Okay. So yes, now again, sine log x is constant. Okay, and this is your x minus integration of derivative of first. So derivative of this now. So derivative of sine is cos. Don't forget 1 by x, and integration of 1 is x dx. Can you see this over here is nothing but I only, minus I. So it is going to be what? 2I is equals to x if you take common, cos log x plus sine log x upon 2, because this 2 will go out. So x by 2 cos plus sine, option C. Yes? Clear? Now understand, e power ax sine bx type of integration. Integration of the type, ma'am, there you missed minus sign after differentiating cos of log x. No, I didn't miss minus sign, did I? I don't think so. Which minus sign? After differentiating cos. No, the minus sign became plus now. Minus is for formula, and then because cos derivative is minus sign, so I wrote plus sign. Correct, na? Integration of the type e power ax sine bx. Okay. Alright, so Eilert rule, let's apply. Eilert rule says that this is going to be the second function, this is going to be the first function. Sine bx constant, and integration of this, tell me, minus integration of derivative of first function. So b cos bx okay, b cos bx, and integration of second, so e power ax upon a dx. Again, can you see? Again, similar type of e and cos, exponential cos, exponential and trigonometry is there. So this is I is equals to e power ax upon a sine bx minus b upon a, and you know what, again this is going to be the first, this is second. First function constant, integration of second minus integration of derivative of first. So cos derivative is minus sine, a little bit lengthy I know, and integration of second. Oops. Okay. Can you see again? This is same thing which we are trying to integrate. This is your I only. Okay. So I is equals to what? E power ax upon a sine bx minus b upon a square cos bx e power ax. Minus minus, minus plus minus, and you know what, this is b cancels, so just b upon a. This should be what? The derivative here. This is a, right? This is a. So now a square, b square by a square I. That's it. Okay, so if you solve it, I will come out 1 plus b square by a square, and you know what, if you take LCM, a e power ax sine bx minus b cos bx upon a square. See, I'll show you the final thing, which is this. See, it is going to be I and a square. A square anyway cancels. So a e power ax sine bx minus b cos bx, e power ax is already there. Okay, here also. Upon a square plus b square, correct? So this is how it is going to get. See, e power x, if you take common, this is how it is going to be. Lengthy, right? But yes, slightly lengthy, but you understand the process also. E power ax sine bx, e power ax upon a square plus b square, a square plus b square. Now a sine bx, b cos bx, a sine bx minus b cos bx. So this is how you need to integrate. These are the two formulas that you have to keep in mind. E power ax sine bx we just did. Now e power ax cos bx. Similarly, we'll integrate, we'll realize that okay, sine will become cos, cos will become minus sine. Not very difficult to remember, but yes, slightly lengthy. Do not worry. Solve a couple of problems, automatically it will come in your brain. Okay? Yes? Chalo. Now, if I give you one question, e power 2x cos x, will you be able to integrate that? Chalo, let's integrate. E power 2x cos x. So this is e power 2x will be common upon a square plus b square, 2 square plus 1 square. So 2 square plus 1 square, bracket. Now a cos bx, a cos bx. So 2 cos x plus b sin bx. So that means 1 sin x, just sin x. If you know the formula, can you see how easy it is? So this is how your answer will look like. Can you see? Yes? Clear? Give me a big thumbs up if you've understood it. Because now after this, a very important topic which we are going to study, both for definite and indefinite integration, this topic is very important. Okay? Which is nothing but two classic integral. 2 classic integral. 2 classic integral. Okay. Very easy also, but sometimes it might look a little bit tricky also. See, the formula says that e power x fx plus f dash x. E power x fx plus its derivative. If you need to integrate this, the answer is e power x fx. Now, what I am going to do is, I am going to tell you this proof by reverse process. Okay. So, can you just help me in differentiating this e power x fx? How will you differentiate this, ma'am? Differentiation, 2 product, easy. First function constant, differentiation of second plus first function, this time derivative. So, e power x derivative is anyway e power x, and this time fx will be kept constant, right or wrong? So, that means e power x f dash plus f. Okay. So, derivative of this is what? E power x f dash plus f. So, integration will be what? This. That's same as this. Integration of e power x f plus f dash is what? E power x into f. Okay. Yes. Now, in this type of questions now, in these type of question, understand, you don't have to integrate. You don't have to differentiate. You don't have to do anything. You just have to focus on identification. 99% question is done if you are able to identify that. Okay, this particular question is from 2 classic integral, one of the 2 classic integrals. Okay, so over here I think this one identification is not very difficult. E power x is already there, so I am just looking for inside the bracket there should be a function and there should be its differentiation. That's it. So ma'am, let's separate it na. X upon x square, ma'am, 1 by x minus 1 upon x square. Okay, dx. If this is your fx, if you differentiate with negative sign only, with sign you are getting f dash x. So yes ma'am, e power x fx plus f dash x, so we are getting. What is the answer then? The answer would be e power x into fx plus c. So e power x, identification is done, the 99% job is done, just put the value of fx. So this is your answer, e power x into x. Where are you? Hi. Sorry, into x nahi, upon x. fx is what? 1 by x, no? Option A. Okay, clear? Chalo, let's do this question. Let's see how many of you can do this question. E power 2x, 1 plus sine 2x, 1 plus sine 2x, can I write sine x plus cos x whole square? 1 plus sine 2x is what? Sine x plus cos x whole square. And this is what? 2 cos square x. Okay. Yes or no? Gold. e power 2x by 2 is already there, and you have sin x plus cos x upon cos x whole square, e power 2x by 2, tan x plus 1, so basically 1 plus tan x whole square. So e power 2x by 2, 1 plus tan square x plus 2 tan x. Is it making sense or not? I don't know. 1 plus tan square is sec square. Oh yes, plus 2 tan x plus c. Yes, it is making sense. Okay. First of all, what we need to do is we need to take 2x is equals to t, so that x dx is equals to dt upon 2. Okay. So e power 2x, e power t, okay, x, x dx, no, dx is equals to, right, sorry, there is no x, no, dx is equals to dt by 2, so this is your dx, dt by 2, so dt by 2, this is your dt. Now what about this, sec square x, so sec square t by 2, and this is 2 tan t by 2. Yes or no? Yes or no? Okay. Now understand, if at all this is my function f of t, what is the differentiation? Ma'am, differentiation tan theta differentiation is sec square theta. So 2 tan t by 2 differentiation will be what? Ma'am, 2 sec square t by 2 upon half. Sorry, into half, 2 to cancel. So this whole thing will be f dash t. Yes or no? So now the integration is actually e power t by 4 into f of t into 2 tan t by 2 plus c. 2 ones are 2 twos are. So now just put the values, e power 2x tan x upon 2 plus c. E power 2x tan x, option C. Okay. Do you want me to repeat it one more time? I can do that. Okay. First of all, I realized that this needs to be solved first thing. So 1 plus sin 2x is sin x plus cos x whole square. Okay. 1 plus cos 2x, gold, 2 cos square x. This half can come in front and this whole square can be taken in complete sense. Sin by cos is tan, cos by cos is 1. Now let's expand it. 1 plus tan x whole square. A square plus b square plus 2ab. 1 plus tan square can be written down as sec square. Now the problem here is that this is in 2x and this is in x. My formula is always in e power t is already outside. So let's do one thing now. Let's put 2x is equals to t so that dx is dt by 2. Let's convert it into t. So it is e power t upon 2 was already there, but 1 by 2 is already there. Not dx will be dt by 2. So dt by 2, that's why this 4 is there. Now just turn. X is what? T by 2. Sec square t by 2, 2 tan t by 2. Now just understand the same thing. Now we need to work on that integral. E power thing is already there. One should be function, other should be its differentiation, which is already there. You differentiate, you will get this. Everything is adjusted now. So your answer will be e power t by 4 2 tan t by 2. Just convert everything in terms of x, you will get your answer. Okay? Clear? Clear, clear, clear. Do we need to solve another question? JEE main question, by the way. JEE main question. 1 plus x minus 1 by x. Okay. E power x plus 1 by x. Okay, sorry, but before that, okay. Not right now. See, one more question. Just tell me the differentiation of x, f of x. Tell me the differentiation of this. Derivative of this. So, ma'am, differentiation will be x, f dash x plus f of x. Acha. So, then tell me the integration of this x, f dash x plus f of x. Will be what? Ma'am, x, f x. So, basically, now you have to identify what? That e power x was slightly visible. Because the moment you see e power x, you might think that, okay, maybe it is from the 2 classic integral. Okay, so this is the second one of 2 classic integrals, second formula of 2 classic integral. Okay, and identification of this is slightly difficult. So you have to hit and trial. You have to think, acha, this question is not working with substitution, not with partial fraction, not with this, not with that. Maybe it is the second classic integral. No formula is applicable. Okay, so now let's do one question. 1 plus x minus 1 by x e power x plus 1 by x dx. Okay, now very first thing would be that let's put x plus 1 by x is equals to t. Okay, or if not, okay, let's do one thing. Let's multiply this. So, e power x plus 1 by x. Can you see I have multiplied it over here? Plus x minus 1 by x e power x plus 1 by x. Okay. Alright. Now, can you differentiate this x plus 1 by x? Now, if you differentiate this, you are going to get 1 minus 1 upon x square. 1 minus 1 upon x square. Okay. Acha, can I take x common from this? See, if you differentiate na, x plus 1 by x derivative, keep in mind, ma'am, 1 minus 1 by x square. I need to create this. If I take x common, what will I get, ma'am? 1 minus 1 by x whole square. Okay, that means you got it. Yes, absolutely. Okay, so now understand. This is your f of x. Now, if you want to differentiate this, f of x, what will you do? So, ma'am, easy, e power x derivative will be what? E power x multiply using chain rule. So, this whole thing, see x plus 1 by x, if you differentiate, you will get this. So, this is your f dash x. And your x is also there. Can you see that fx plus x, f dash x is getting created? Fx plus x, f dash x is getting created. Whose integration you are interested in, right? So, integration of this will be what? X into f of x. Yes or no? Slightly difficult. Have a look. I'll give you a solution one more time also. See, this is how it is. This was it, 1 and x minus 1 by x. So you multiplied it. This is 1. Now what we did is we just took x common from this, x and this. Now clearly this is f of x and this is x. This is completely f dash x. So fx plus x f dash x you have to create. Once it is identified, then 99% of your problem is solved. You just have to apply the direct formula. Okay? Yes? Chalo. Next question. First of all, e power ln. We know this, right? This is actually, if you modify, na, this is x and this is sin x minus cos x. Not a very difficult question. Okay, can you see if your minus cos x is a function, minus cos x is a function, plus x times derivative of minus cos x is what? Derivative of minus cos x is minus minus sin x plus sin x dx. So can you see this is your fx, this is your x, this is your f dash x. So integration will be what? X fx. So minus x cos x plus c minus x So I think this is wrong. This is correct now because this is minus x cos x. This is more appropriate. So option C is absolutely right. Okay? Yes? Chalo. Next question. Next question ready now. This question, I want all of you to do this question. See, if we can put ln x is equals to t, will it help? X will be e power t. So dx is equals to e power t dt. Now let's convert. Integration of dx will be what? E power t dt. Okay. Now ln t plus 1 upon ln t square. Okay. Sorry. Not this. This is actually 1 by t square. Correct? Hmm. Yes, some noise is coming. Still coming, kya? Let me add some noise cancellation. Is it better? I have activated noise cancellation also. Now I think I need to add something. Okay. Yes. So e power t ln t plus, let's add the derivative of it. Ln t. So if I differentiate, it will become 1 by t. I have added 1 by t and I will subtract 1 by t plus 1 by t square. Now it will make more sense because two things are getting created. Understand? See, this is what? E power t. This is your fx. Fx. And this is your f dash x. Remember? Two classic integral first formula. So e power t fx plus f dash x. So this much part is sorted. The answer would be what? E power, sorry, this is t. Answer would be e power t into f of t. So this part is done. E power t and ln t. Correct? Now minus sign if I take common. So this is 1 by t and minus 1 by t square. If you take minus 1 by t common, this is your g of t and this is your g dash t. Minus sign common, 1 by t derivative is what? Minus 1 by t square. Or you take minus 1 by t only. Gt is minus 1 by t, derivative is this. So now again e power t is already there. So, this is going to be minus e power t and this is upon t plus c. Basically, simultaneously two formulas are getting created. Two same formulas. Now just e power t. What is e power t? X. What is ln t? So ln of ln x minus 1 by t square is fx. Why? Why, Gokul? See, derivative of this is this, na? Now, e power t is x, t is ln x plus c. Let's see. X, ln x minus x. Can you see option D is absolutely cool over here? Very good question. Very good question. Yes, everybody? Getting it? Okie dokie. Chalo. Now, slightly difficult part, but not difficult. It's a formula based. So remembering formula is slightly headache for us, right? But don't worry, I'll make it easy for you. Square root a square minus x square. Remember, 1 upon square root a square minus x square was related to sine inverse x by a, but it was in denominator. Now it is in numerator. So again, sine inverse x will come into the picture, but it is going to be 1 by 2 x, copy paste, half x, copy paste, plus half a square, and you know what, your very own sine inverse x by a. Just remember this formula. Okay, how to solve it? A square minus x square, just put x is equals to a sine theta and dx will be a cos theta d theta, and convert this. So this is going to be a square minus x square. So this is going to be 1 minus sine square, which is cos, and one more cos from the dx. So this is how it is. Cos square theta integration will be done by gold formula, 1 plus cos 2 theta by 2. Okay, and this is how it is going to be. And you just have to now integrate it. After integration, put the values, you will get it. Okay, but that's how you need to remember. Square root a square minus x square, half x, copy paste, half a square sine inverse x by a. Okay, similar formula over here. Remember, we saw that formula 1 upon square root x square plus a square. It was in denominator in the root. So the answer was log of mod of x plus copy paste. We just did it. Okay, now this is in numerator. Whenever it goes in numerator now, then the formula will be slightly difficult. Okay, so it is going to be half x, copy paste. Again, half x, copy paste, plus half a square, the previous old formula. That's how you need to remember it. Okay, same here also now. Half x, copy paste, half a square, previous old formula. Let's do. So this is how this is how it is. And same, square root x square minus x square is also half x, copy paste. Now this time minus sign, half a square log of x plus square root x square minus a square. Can you see this? Now let's solve this question. Square root x square plus a square, bam. Okay, half x, copy paste, plus half a square. So this is a square. And you know what? Previous old formula, which is log of x plus copy paste. That's it. See, understand the pattern, you will be done. So this will be your answer. Okay. Next question. Done. Next question, 3 minus ln x. Again, in this question, it is pretty obvious. First, we have to put ln x is equals to t, so that 1 by x dx will become dt. Integration of square root of 3 minus t square upon is not there. Now 1 by x dx is gone. It has become dt now. So square root a square minus x square. What's the formula? Square root a square minus x square. The formula is that sine inverse. Okay. So 1 by 2 t by 2 basically. And then we have copy paste. Plus 1 by 2 a square. And same old sine inverse. Now put the value of t. So ln x by 2 square root 3 minus ln square x plus 3 by 2 sine inverse ln x by root 3 plus c. Yes? Okay. Is it difficult? It is not difficult. See? Okay, now 3 special type of integration. Now let's understand that see, now this part of integration, whatever we are starting now, this will tell you about that if you get this, do this. If you get this, do this. So you just need to remember the format. Okay, so integration, indefinite integration, some people feel that very difficult. But you know what? It is not very difficult. It's just that there are so many things to cover. If you talk about difficulty level would be that you have a question and you're not able to think about the answer. Indefinite integration might look difficult to you only because you don't know the formats. Okay, it can be mastered. If you give time, indefinite integration will reward you. But there are some chapters, even if you give time, syllabus is also very small, but thoughtful. It is so thoughtful. Suppose probability, permutation and combination, then complex number also. Okay, so these are the difficult ones in terms of thinking. Indefinite integration is testing you on a lot of things, memory also. So if you are doing hard work, indefinite integration will reward you. But in probability, PNC, even if you do hard work, you keep on doing hard work, it will not reward you like that. For that, real intelligence, real brain will be required. So this is not a very heavy chapter, but not difficult. Okay. Whenever you see 1 upon quadratic, 1 upon root quadratic or root quadratic, three things. Same medicine. Three type of integration, same medicine. 1 by quadratic, 1 by root quadratic, root quadratic. Just make perfect square. I hope that you know how to make perfect square. For example, this. Root quadratic. Make perfect square. So x square, so please add 1 and subtract 1. So this is x plus 1 whole square minus 2 square. So this will be treated same as square root of x square minus a square. It will be what? X by 2. Okay. Then copy paste. Or rather write the direct one. No? Eventually you will solve it only. So x square plus 2x minus 3. Okay. Minus 1 by 2. This had a minus sign. Minus 1 by 2 a square. And the previous same old formula log of mod of x plus copy paste. I'll tell you which formula I'm talking about. So I am talking about this formula. Square root x square minus a square. Now half x copy paste minus half a square. Same old formula. So same, see, I have applied it same. X plus 1, this is x by 2, copy paste. Minus half a square, same old formula. Okay. So your answer will be what? But please understand, this is log of x plus, so this is x plus 1. So can you see this is half x plus 1, your question, minus 4 by 2, log x plus 1 plus same thing. Yes? Okay. So this is how it is. Now the next question. Integration of x upon x power 4 plus x square plus 1. Okay. So now this time x square will be assigned as t, so that x dx will become dt upon 2. X dx will become dt upon 2. Okay, so integration of x dx, dt upon 2. And this is going to be t square plus t plus 1. And I told you, 1 upon quadratic, whenever you see what to do, just make it as a perfect square. So this is dt upon, how to make perfect square? I hope everybody is aware. T square, so this is t plus half whole square minus 1 by 4 plus 1. Okay, so basically you have to take half of the coefficient of t. half of it. So t plus half whole square, and you need to square and you need to subtract the square of half. That's how it is. So this is 1 by 2 dt upon this is what? T plus 1 by 2 whole square. This is plus 3 by 4, which is root 3 by 2 whole square. Do you remember? This is 1 upon x square plus a square. So 1 by 2 is already there. What's the formula? 1 by a tan inverse x by a. 1 by a tan inverse x by a. So 1 by a, that means 2 by root 3. This is a. 1 by a tan inverse t plus half upon a. Okay. Now you can just change. So it is going to be 1 upon root 3 tan inverse. Okay. And if you multiply 2, this is 2t. So 2x square plus 1 upon root 3. And this is plus c. So 1 by root 3 tan inverse. Can you see option C clearly? Is absolutely right. Yes? Okie dokie. Clear? Format change. So what was the previous format? Quadratic, root quadratic, 1 by root quadratic. Whenever you see that, just convert into perfect square and eventually one or the other formula will fall into the place. Now whenever you see linear by quadratic, linear by root quadratic and linear into root quadratic, can you see the format is same? Previously it was 1 by quadratic, 1 by root quadratic and root quadratic. These were the three things. Now the linear got attached. So linear by quadratic, linear by root quadratic, linear into root quadratic. So your linear should be expressed as constant multiplied derivative of quadratic plus b. I'll show you what I'm trying to say. See, suppose this. Can you see linear upon quadratic? So your 2x plus 1 should be expressed as a times derivative of this main quadratic. So derivative will be what? 2x plus 2 plus b. Okay. So what will happen? Now tell me. So ma'am, clearly 2ax, compare. So a is equals to 1. 2a plus b is 1. So 2 plus b is 1. So b is minus 1. Okay. So 2x plus 1 now will become what? Change. 1 time 2x plus 2. Okay. Minus 1. Okay. Upon this is what? X square plus 2x plus 2. And this is again x square plus 2x plus 2. The first half of the integration. How will you do it? Just put this as t. Put this as t. This is your t. With dx, this will become your dt. So this is what? Log of mod of t. Easy. Minus. What about this part? Now this part was 1 upon quadratic, no? We have learnt it, just perfect square. So this is what? This wala part is 1 upon x plus 1 whole square plus 1. Remember, 1 upon x square plus a square integration tan inverse. So 1 by a. A is anyway 1. Okay, so this is tan inverse x plus 1 by 1 plus c. Tell me, is it difficult? Not very difficult, right? See, so what we did? 2x plus 1, the numerator, the linear part is written down as a times derivative of quadratic plus b. On comparing, you can get the coefficient and now write it as 2x plus 1 will be 2x plus 2 minus 1. So this is I1, this is I2. So this is the very easy. Now if you put t, this will be dt. That's why we did this. And this was The previous category, previous format, integration number 2 will be what? Like this. So integration of this, perfect square and easy peasy. So your final answer is this. Okay. Chalo. Now, shall I give you one homework question, x plus 1 upon, or do you want me to do it right now? Homework or right now? Chalo, let's vote. Homework or right now? Is the sound bothering too much? Is this sound bothering too much, kya? I don't know, because noise cancellation so I have activated. I don't know how it is coming across. Homework, so yes, again, x square plus x. Sorry, x plus 1 will be a times 2x plus 1. See the derivative plus b. Now just compare. So clearly a will be half, and this is b is also half. Okay. See, if a is half, b is half. So now half times 2x plus 1, half times this. So now if you put this as t, this will be dt. So this is 1 upon 2 root t. What is the integration of 1 upon 2 root t? It is just root t. So answer will be what? Directly square root x square plus x. And for the second part, you have to make it as perfect square. This is 1 by 2. Now make it as perfect square. So x square plus 1 by 2, x plus 1 by 2 square minus, okay, so this is square root of x square minus a square in the denominator. So it is going to be what? Square root of x square minus a square in the denominator. So this is very simple. This is plus half, and you know what? Log of mod of x plus copy paste. Here x is x plus half plus copy paste. This is how the problem is going to be. I'll show it to you also. See, half log this. See, this is your final answer, right? I told you, no? This and this. Okay, clear? Chalo. Now this is something which is really important. Okay, and maybe let me check one time. Maybe this is our, yes, not the last. Okay, no, we have a little to cover. Okay, so this is very important. That's what my whole idea was. Okay, so yes, what is this? Integration of the type x square either plus 1 upon x power 4 plus kx square plus 1 or minus 1. See, okay, so this is the category of question. Now there are two categories. We'll tackle one by one each category. Okay, so very first category, chalo, let's do it by question only. Okay, so this is the pattern: 1 plus x square whole upon x power 4 plus 3x square plus 1. So basically in the numerator it will be either 1 plus x square or 1 minus x square. In the denominator there will be x power 4 plus 1 plus kx square. Okay, understood the pattern? Now whenever there is 1 plus x square, you have to put x minus 1 by x is equals to t. When depends on the numerator. If numerator is 1 plus, If numerator is 1 plus x square, put x minus 1 by x is equals to t and divide the whole numerator and denominator by just x square. X square come out, x square come out. Okay. Now put x minus 1 by x is equals to t. Differentiate. So ma'am, it will be 1 plus 1 upon x square dx is equals to dt. Now do you know, if there is a plus, why did I actually put minus as t? Because upon differentiating, this sign will become plus and this is what you're going to get. Okay. This is how we do substitution. Substitution is based on, eventually we need to vanish the numerator or vanish the thing which is in product with dx. Okay. So this is dt. Now what about x square plus 1 by x square, ma'am? So x square plus 1 by x square is actually x plus 1 by x whole square. But you know what? If you're going to open it, a square plus b square, it is going to be plus 2ab. So you need to subtract also. So x square plus 1 by x square will become what? X plus 1 by x whole square minus 2 plus 3 will be plus 1. Okay. And this is nothing but what? This is your t only, no? Oops. No. Wrong. Because see, how can I put t? Sorry, wrong. I need to write it in terms of x minus 1 by x. Now tell me. So ma'am, if now I open it, it will be x square plus 1 by x square minus 2 will be there if you open it. So to compensate, you have to add plus 2. Okay, so now it's clear. It is going to be what? X minus 1 by x whole square, and it is plus 2 plus 3. So plus 5. And this is anyway t. So it is dt upon t square plus root 5 square. Now do you remember which formula is this? Tan inverse t upon root 5. Right or wrong? 1 upon a, please do not forget, plus c. Now you can just convert, this is 1 by root 5, tan inverse x minus 1 by x by root 5 plus c. Yes? See, this is the answer. Any issue, any problem? Are you getting it? Okay, so whenever you see 1 plus x square, put minus as t. But now when you see 1 minus x square, put x plus 1 by x is equals to t. So it is going to be what? 1 minus 1 by x square dx is going to be dt. And also if you square it also, no? It is x square plus 1 by x square plus 2 is equals to t square. Square it both the sides and put. Now what you need to do is take first of all x square common or divide by x square. So 1 by x square minus 1 whole upon x square minus 1 plus 1 by x square dx. Now this is what? Minus dt upon x square plus 1 by x square is t square minus 2. So t square minus 2 minus 1. Now do you remember this? dt upon, this is what? 3 minus t square. Remember a square minus x square wala thing. So this is root 3 square. So 1 upon 2a log of mod of a plus x. So root 3 plus t. And root 3 minus t plus c. Okay. All right. Clear? So this is how it is. But it had a negative sign. We don't have a negative sign. That's why answer will be slightly different. Okay. Eventually, we need to anyway absorb the negative sign. Now, again, this type. Now, ma'am, what is this? You were teaching something else. Now, this is something else. What is this? So, integration of the right type root tan x. Integration of the type root tan x or root cot x also, or root cos x, cot x. Both are actually lying under the category which we have just studied. Okay, which is what? So just put tan x is equals to t square. So tan x is equals to t square, correct? So tan x. Now sec square x is equals to 2t dt dx. Okay, now you'll be like, ma'am, hold on. Yes. So dx will be what? 2t dt upon sec square x. Sec square x. Can I write sec square x as 1 plus tan square x? 1 plus t power 4. So now convert. Integration of root tan x. So root t square is t. Okay, ma'am, clear. Now what? Now your root tan x is t. Now your dx. Dx will be what? 2t dt upon 1 plus t power 4. So ma'am, what did you get? 2t square dt upon 1 plus t power 4. Okay, now what you need to do is, you need to just add and subtract 1. See. 2t square. Now you'll be like, ma'am, but still we didn't get that form. I'll show you. Whenever you see t square upon this t power 4 plus something, see, t square is there. See, denominator is there. Denominator is correct, but numerator is not there, ma'am. Because numerator either should be x square plus 1 or x square minus 1, like that. So we'll create both. Now this is t square plus 1 plus t square minus 1. And this is t power 4 plus 1, t power 4 plus 1. Integrate with respect to dt. Now what? How to differentiate, ma'am? Both. Yes, both. Plus or minus together. So this is a different, this is a different. Now take, so this is 1 plus 1 upon t square. This is t square plus 1 by t square. Integration. Plus, what about this? Take common, so 1 minus t square plus 1 upon t square dt. So now just understand. In here you put a minus 1 by a is equals to t. Sorry, t minus 1 by t is equals to a. T minus 1 by t is equals to a. And this is t minus t plus 1 by t is equals to b. Right or wrong? So this, if you differentiate, you will get dA. I1 will be what? dA upon. Now this t square plus 1 by t square. So this is minus 2. A square plus 2. It is going to be what? 1 by a tan inverse a by root 2. What about I2? I2 will be again dB upon. If you square it, t square plus 1 by t square plus 2. So it is b square minus 2. So this is b square minus 2. So this is nothing but 1 upon 2 root 2. Remember, log 1 upon x square minus a square. So 1 upon 2 root 2 log of. This is what? X square minus a square. So it is going to give you, if you take minus sign out, so a plus x, 2 plus b. So 2 plus b will be here, and root 2 plus b and root 2 minus b. And you know what? Eventually you have to turn this into t, then x. Okay, so I'll show you also. See, this is your first integration. This is your second integration. What we did was, over here, t minus 1 by t will be p. So this is, so we have calculated only. And that second integration, let me tell you, this is the first only, right? And now in the second integration, t plus 1 by t is z. So that's how it is. So this so we have done already. And it will be log. This is your log. Eventually the final answer will be what? This is your I1, this is your I2. Now t eventually will be replaced by root tan x. A little bit lengthy, but so this is for you. I am leaving this for you. Indefinite integration. You should understand the process, but at least. Okay. All right. Clear? Chalo. Now what we will do is, we'll continue. See, we'll keep it till here only because I know things are getting heavy in integration. So now I think what is pending, let me tell you, that this kind of integration, linear, root linear, quadratic, root linear, that we will see in the upcoming session. Okay. So some special kind of integration is something which is left, and apart from that we have partial fraction as well, and kutur putur plus some miscellaneous. Okay, so we will need one more lecture for that, probably one, or let's say two, I don't know, but one or two. After that we'll be done, because indefinite integration is such a huge chapter. So yes, let's keep it till here. We'll meet in another session which is going to happen next week, right? Okay. Okay. Chalo. Bye bye. See you. Bye bye.